All right, so we are going to look at how to graph a parabola that is written in vertex form. So I have written at the top of this page here, vertex form of a parabola. And hopefully you have already completed your Desmos activity where you investigated what A, H, and K all do in the quadratic graph. So the first thing to recognize is, yes, A is the exact same type of deal as the A in the standard form parabola. So this A here, that tells you width, how wide or how narrow it is. And it also tells you whether or not if A is positive or negative, it tells you if it opens up or down. So those are the two ideas that you can get from just looking at the A. You can see how wide it is, you can see if it opens up or down. Now H and K are great, and this is actually why it's called vertex form, because the value of H and the value of K tell you your vertex. So the benefit of having something written in vertex form is that you can immediately see the vertex and you can see if it's going to open up or down. So that'll tell you if that vertex is going to be a maximum or a minimum. So the vertex is going to be H, comma. One thing to really recognize is that in these parentheses, it says X minus H. So that H value, similar to when we were graphing circles, the H value is going to be opposite once you put it into the graph. The K value is plus sign, so that's going to be same as. So I'm going to look down below at my first example. So notice I've got my A value here of -1. So right off the bat, I know that this is going to open down. The other thing I can see right off the bat is that my vertex is going to be 2, 1. Notice it says X minus 2. So I know that the X value is going to be 2 plus 1 gives me my Y value of the vertex, which is +1. So this here is my vertex. That is the first point that I can plot on my graph. So 2, 1. There we go. From there, I know that the vertex always goes through my axis of symmetry. So I know my axis of symmetry, some people say AOS for short, my axis of symmetry is going to be at that X value of 2. So I can go ahead and do my dotted line for that as well. And now from here, I can make my table, same way I've been doing my table before. So in order to make my table in this, I'm going to put my vertex in the middle. So if I have 1, 2, 3, 4, 5 slots, my vertex goes in the middle, 2, 1. Now every time I make a table, keep in mind we're doing this as like a number line. 5, 2, 3, 4, and then 1, 0 up here. So now I'm going to just plug in the values and see what happens. So first I'll do the 3. And I'll have negative, plug in 3 for x, so 3 minus 2 squared plus 1. Now keep in mind your order of operations here. So I'm going to do 3 minus 2 first. So I've got 1 squared with the negative outside and then plus 1 on the end. 1 squared is next what I'm going to do because that's my exponents. So that's 1, negative out in front, -1 plus 1, and I get 0 for this. Now because this is my vertex and this is on my axis of symmetry, I know that this is also going to be 0. So I have 3, 0, and I have 1, 0. Now if you remember, these are also called your roots, your solutions, your x-intercepts. So those are important in this problem. So now I'm going to plug in 4. If I plug in 4, I get negative 4 minus 2 squared plus 1. That's going to be negative 2 squared plus 1. So I've got negative 4 plus 1, which is going to be negative 3. And again, since that's a negative 3, this is going to be negative 3 as well, which is great because I just found my y-intercept as well. And I can draw my parabola through here. So there is an example of graphing straight from your vertex form. So the best part about vertex form is that it automatically gives you the vertex. If you think back to standard form, the best part about that is that you were given the y-intercept right off the bat. You are not given that in this situation. So in order to find the y-intercept, you either need to recognize it through the axis of symmetry, or you need to plug in the value x equals 0. If you need another example, there's going to be another example posted as well.